Hi all, welcome to Graphics Desk.
In this video, we'll talk about how to draw orthographic projections of the given object. Now, what we have here is, there are a few things which we'll note before we start. So this is the direction X which is given to us. This is the origin point. The angle of projection that we have to use is first angle method. And what we have to draw is, we have to draw front view, top view and right hand side view. So in first angle method of projections, you'll have front view on the top, you'll have top view on the bottom, which is below XY line, and the right hand side overview will come on the left hand side of the front view, which means if you consider this as the board and four sections of it, this is where your front view will be, this is where your top view will be, and this is where your right hand side view is going to be. So if we divide this sheet into four different parts, we'll get a clear idea in terms of where each of the view would be. So let me draw an XY line first. So this is our XY line, which means on this side of the top side of this line, there'll be front view and top view would be at the bottom. But let me divide this vertically also, so that it will be easy for us to take the projections when we go to RHSV. Okay, now we have divided this sheet in roughly four sizes, four different parts. Now, while starting with the front view, we have to take some margin above XY line, and then we have to start. Now, in the front view, what we have is the overall dimensions of it is 115 mm in the direction parallel to XY, and 50 mm is the height, overall height of this particular object, which means this whole geometry or whole object in front view would be contained inside 115 rectangle of 115 as length and 50 mm as height. And if we talk about the top view, again it is 50 mm and 115, which is this dimension. So our top view would also have the same dimensions as 50 by 115. So let me start with front view, and by taking some margin above XY line, I'll draw a line parallel to it, which will be the base of the front view. Okay, so I've taken these two lines and our geometry would lie into this rectangle. Now, of course, this distance from XY and distance from this vertical line is essentially has no dimensions, but it will be useful for us if we have to give dimensions. We can use this space. So let me first mark this 115 mm, which is the base of the object in the front view, and 50 mm, which is a vertical height of the object. So 115. Which is here, and 50 mm. Is here. So if I simply construct a rectangle, which will give us the extent of this object in the front view. Okay, so our front view would be inside this box only. Okay, now what we have given is, we have measured the height 50 mm and 115 mm. The height on the other side is 30 mm, so we'll measure this 30 mm, and there are multiple dimensions that we'll mark on this line, which is 15 mm, 30 mm as the diameter of this hole, or a semicircle, it will appear in the front view, 20 mm, 20 mm, which is 40 mm, and 20 mm from this particular face, which will be the top face, and then we'll talk about the slant face. So let me measure this 30 mm first, which is a vertical line, and then we'll measure these distances. Now what we have is 15 mm, 30 mm, 20 plus 20. Now next 30 mm would not be a solid line. I don't have to draw it, but this is a 30 mm and the center of it is here, what we have. Again, 40 mm in this direction, which means up until this point. And this is where the center of it is. That means this is 20 and this is 20. So from this point. Okay, and we'll measure 20 mm on this line. Now, at this moment, we are going to locate the slant face, or this particular face, which will be represented by the slant line connecting this point as against this one. Now, we have already located the center of this particular semicircle. So we'll construct the semicircle first, and then we'll go to this hole, which will be visible in the front view as dotted lines. So let me draw the semicircle first, with this being the center and 15 mm as the radius. Okay, so this is how this circle will look like, this particular circle I'm referring to. Now, once we're done with this, we already have located the center. The dimensions of this hole is given as 520, which means 20 diameter, which means radius is 10 mm. So in the front view, I have to draw 10 mm in this direction, 10 mm in this direction, and the dotted line through those points. Okay, so our front view is complete. Now, for us to draw the top view, which will be here, we have to carry the projections of these object over here. So let me carry these vertical projections here, and then we'll measure on these whatever the dimensions of this diagram that we have. Now, the top view would be very simple because it is simple rectangle, just the hole in it, and all the vertical lines or the lines which will be vertical lines in the top view are anyway coming from the projections. So let's draw the top view. Now again, we'll take some distance from the XY line and we'll draw a line parallel to it for the entirety of these projections that we have taken. Okay, now this particular line is basically this face represented as line. So as I said, the top view would be a simple rectangle of 115 mm, which we have already drawn a line of. 50 mm we have to measure now. Okay, and this face is also a solid face, which will be 50 mm apart. So I have to draw a line parallel to this, and also this will be the dark line, which is define the boundary of it. Okay, now all of these lines in the front view, in the top view, would be solid lines, except this will appear as hole. So all of these projections that we have taken from this point, this point, this point, and this point, we have to make as a solid line. Okay, now this dotted lines, what we have is basically a hole, which means there will be a circle at this place, which has its center exactly in between of this entire width of the object, which is 25 mm from either of the face. So let's locate the center first. So this is the center, and with radius is 10 mm, we draw a circle. A very quick checkpoint here is that your circle will simply touch to these projections that we have carried from the top view. Now with this we have completed with our top view. Now let's draw the right hand side view, which will be here. So for this, what we'll have to do is we'll have to carry these projections from the front view in this section, and from the top view we have to rotate these projections. So there are two ways to do it. How to do it from the top view, where you can, keeping this as a pivot point, you can draw circles, or you can draw a 45-degree line, and you can simply draw horizontal and vertical projections from that. So what I'll do is I'll mark a 45-degree line over here from this point, where our vertical line and XY meeting. Okay, so this is that line. And now these projections will come until this point and will go vertically up, giving us the intersection to have our right hand side view. So let me mark the horizontal projections first. Now we have got the horizontal projections. There are only 4 projections because one from this face, the other from this face, the next is the bottom of the semicircle or cylinder, which will be a dotted line in the view, and the bottom of it. So these are the 4 projections that we have. Now the geometry on the right hand side view, where the observer is looking in this direction, the maximum boundary of it is 50 mm in width and 50 mm in height. So it will be a square diagram in the right hand side view, and as you carry the projections, it will take its shape. So I'm carrying the projections from the top view now up until this point, the line which we have drawn as XY line. Okay, so now once we have these points meeting on this line, we have to draw these projections vertically. Again, parallel to this line, vertical line that we have already drawn. Okay, so this is in this box our view would lie. So let me draw the border first. So this projection is coming here, this point. So what is the boundary of this object, which I have already mentioned as square, which is this one point, second point, third point, and the fourth one. So let me darken that. So this is the boundary of our right hand side view. Now what we have is what all objects would be visible as dark. Now when we are seeing from here, the bottom of this cylinder or semi-cylinder, which is projection from this, will be a dotted line. This is which is 30 mm from origin. This is which is 30 mm from origin would be a solid line, which means this would be a solid line from left to right, and this is anyway solid. And then we have to draw a hole, I would say a vertical line, which is from this point until this would be the dotted line. So this would be a dotted line, these two would be a dotted line, and this would be a solid line. So let me draw that. Now this is how your right hand side view would look like. Now of course we have to quickly mark which view it is. So I'll name these views, I'll mark the center point, and then we'll go to dimensions. Now, okay, I've marked the center lines for all those which are holes. Remember that this center line would extend slightly beyond this face, because the hole has the length up until this face only, not beyond that. So don't draw the center line from the top, which should be essentially like this only. Okay, now let's take a minute to all the dimensions, because our geometry is completed now. Let me give the dimensions of it. So all those dimensions which are mentioned in this diagram, in the problem statement, we have to make sure that all of them are basically given in any of the view. Now generally the thumb rule is that the maximum or more dimensions which are clearly visible in any of the view, those are to be drawn. So I'll quickly do the dimensioning of this diagram. Okay, so with this we have given all the dimensions, and okay, there are many ways of doing the dimensions, like the one that I've given here. If it is very small, you can have dimension arrows pointing inwards. But yeah, this is how your final solution would look like as the orthographic projection of the given object. Thank you for watching this video. We at Graphics Desk committed to spread the knowledge. Be a part of this journey, share this video and spread the knowledge. Until next time, bye.